Hey there, my name is Alberto and I'm developing a stealth 3D game using my own game engine. In today's devlog, we are going to analyze the different components that build up a spawnable laser attack. Let's then have a look to our laser attack in-game. Here we have our player character, which is in front of the trigger for the attack. This is this green box that we have here as a placeholder. Our enemy target is going to be the one we have here with the field of view, and this is the enemy that is going to receive our laser attack. The laser attack entity, or the entity that is going to spawn this attack, is over here. So let's now start the process. Here we enable the attack, we spawn the laser attack. The enemy was crossing at that moment, so it received this attack. We could see how there were some visual effects. It became like reddish, and it also performed like a death animation, which eventually ended in the character disappearing from the scene. Lots of different events happening in a span of few seconds. Let's then have a look on what systems and components we need to build up our laser attack. First of all, we need a trigger in the scene which will allow the player to start the laser attack. The trigger in this case is a box which detects other box overlapping it and actually announces when this happens. When a box enters the trigger, it announces it, and also when the box exits the trigger. And of course, the player character has already a box, which is called a box collider and is used for all the interactions that happens in the physics, and also is used for the triggering system. But a trigger is just announcing that the player has entered. We need something else to start our attack. And this is the interactable. The interactable is listening to the trigger. Whenever the player enters in the trigger, is going to perform some actions. In this case, we are going to trigger a scene event. This event has a reference to this entity over here, which is the one responsible of spawning the attack. So this entity has a component which is capable of spawn other entities, which in this case is going to be the attack entity. Let's now have a look to our attack entity that we just spawned in our scene. This entity has also a trigger, which is again a box which will detect other boxes overlapping. So let's consider our enemy walking across the attack. When the attack recognizes that this enemy entered, what is going to do is to create a hit, and this hit is going to be passed to our enemy, which will process a chain of effects which will eventually end up killing our enemy. But how does this happen? Let's then take a look to the different components that build up our attack entity. So on one hand, we have the duration. So there is a component which is just in charge of disabling the attack whenever it's over. In our case, the laser remains in the scene for about 3 to 5 seconds. Then we want to disable it so that whenever another entity crosses, it's not going to receive a hit. Let's now move on to our most important component. This is the collision heater. This component is listening to the attack trigger whenever the enemy or any entity enters the attack. This collision heater is going to perform some actions. The first action it's going to do is to ask itself, is this entity hittable? Which in other words means, does this entity has a hittable component? If that is affirmative, we are going to create a hit, which is a container with all the information related to this attack, and we are gonna pass it to the hittable. And the hittable is going to process this hit for us. What's going to do the hittable is going to ask itself if this entity has actually health components. That's the first thing. If it has any health component, it's going to apply the damage which comes from the hit information to the health component. And that is the basic action, applying a damage. But we have something else which is very important. Let's zoom out. The collision heater has something called heat decorators. What are these heat decorators? They're basically special effects or actions that we want to give to our heat apart from the basic thing of performing some damage. So as an example, we can have heat decorators, which changes the status of our entities, or which produce a noise effect, or which just pushes back the target. You can define any heat decorator that comes to your mind. And this is what actually makes this system quite generic and usable in many scenarios. Also scenarios which you would not relate at all with the so-called name attack or combat. Let's consider we have three different enemies in this case, or entities, which will receive these hits, which they have a hittable component. These three entities, we want them to be different. We want them to receive this hit and react in a different way. So let's say that the one on the left should not be able to be stunned. The one in the middle should not be pushed back. And the third one, we just want it to be kind of a special, have a 50% less effect. Well, we can do all this with the heat decorators. Why? Because these decorators are processed by what we call heat processors. The heat processors are implemented in the classes that define the enemies. In this case, we would probably have the same class. This is an enemy controller, for example, but each enemy controller has a different data object. And in this data object, we can actually tune these properties, and we can make that the moment they are processing the heat decorator, the reaction is different for all of them. Let me then show you an example of how do I solve a situation by using this attack system, and in particular these hit decorators, without being necessarily an attack or combat scene. Let's consider our player. Our player character, we want it to make or produce some noise when it's walking. How can we build up this system with the attack system that we just presented here? Well, it's quite easy. Let's first think about the trigger. What is our trigger? Well, the player is moving. While the player is walking, we can trigger this every X seconds. And what do we want to trigger? Well, we will spawn an attack, right? And this attack will just have a hit decorator which produces a noise. And this trigger for this attack is going to be a sphere in this case, because we want to make it like a radius and say, hey, if something is overlapping this sphere, should get this hit, should get this noise attack. Let's now consider our target. This is our enemy, which is close enough to the player. Whenever the player is moving, is spawning these attacks, which has this sphere trigger, which is overlapping our enemy. Therefore, this enemy receives this hit. This hit has a noise hit decorator, which will be processed by this enemy. Well, if it has a processor, in this case, let's say that this enemy has a hit processor for the noise hit decorator. What is the reaction? Well, we implemented it in the logic of this enemy. And the reaction, the most logical reaction that we can have here is to face towards the noise. Okay, let's now move on to the depth of the entity. Well, we had this heat that was applied to the health component, and we applied certain amount of damage. Whenever the health becomes zero, in this case, we trigger an event. Well, this event happens on the death component. We have a specific component handling the death, and this component has a bunch or a collection of actions that will happen when it dies. These actions can be anything. This again makes the system quite generic. You can cause whatever you want to happen when this entity dies. In our case, we just want to pull another entity. This other entity will have a component which is called a ragdoll, and we'll also have some visual effects we want to apply, which are mainly going to be color effects. What is this ragdoll and this other entity? Well, let's take a look to the last part. The death component also after triggering all the actions, disables the original entity. We don't want this original entity anymore. It could be conflicting with all the other systems. We just disable it and stop tracking it. So here we have this beautiful scheme in which I show you the original entity being disabled. Then we pull the entity in the same frame, and this, I draw it, depicted it here a bit next to it, but it could be exactly overlapping the original one. So we would not notice that the original one is disabled because we pop up the new one. And this one has a skeletal death animation. It's exactly the same that the original, but what it's going to do the moment it's enabled is just to perform the animation of dying. And at the same time, we have some beautiful, this reddish color effect. Let's take a quick look to these different parts in the editor. Here we have our trigger, what we call it laser trap trigger. It has a box collider, as we said, and we have here depicted as a red box. And this collider is a trigger. So this means that it allows the player to cross it without being blocked. It's not contributing in the physics. This will announce the moment the player enters in. And in our case, we have an interactable. The interactable will only react when the player press the input key. When the player presses the input key, it will trigger the events. And this is what we saw in the scheme. This event is looking for an entity, in this case, this entity down here, which actually, let me look at here, which actually has an attack spawner. This entity spawner will spawn the laser trap. And here we can select the entity we want to spawn. In this case is this attack. If we now take a look to the laser attack, we can see that it consists of 4 different components. Well, the important ones are, first of all, the box collider. This is, again, as I explained, the trigger. And we can see that we also make it super large in height because we want to make sure that any enemy underneath will also be triggered by this attack. Then we have the collision heater, which is the one which was important for us. This collision heater, we define here a damage of 100 points. We make sure we want to kill any enemy that crosses here. And we set up here a layer of enemies. We are only gonna trigger things when it's an enemy, the one crossing. We don't want to trigger it anywhere else. And here we have the heat decorators. So if I click, we can choose the different ones I have defined in my engine. Well, you can just build up the ones you want over here. In this case, we are selecting the pull entity heat decorator and we are pulling a laser heat. And what is this actually? This is actually causing this visual effect that we saw when the enemy crossed it. We had like a particles effect. Well, this is the entity we're pulling here. And as I said, this is another way of decorating your heat. We are just pulling an entity. Let's wrap up by taking a look to the code behind these components. Well, first and the most important component is the collision heater. In this method over here, we handle the moment that another collider enters the trigger. Well, as we said, we first take a look if there are any hittable components. If there are, we are going to create our heat. And this is done through a heat factory system. When we have our heat, we just pass it through the interface heatable to all the heatables. Let's move to the heatable component. Well, the first thing that the heatable component does when it is initialized in the scene, it looks for any health component in the entity. So we cache this and we don't have to look for it every time. The heat method is the one which will process our heat. And first of all, it checks if this heat is actually in the layer that is supposed to be. And if it is, then it's going to process the damage as we showed in the scheme. It checks if there are no health components, it does nothing. If we have a health component, it will create a damage. Again, the damage is created from a factory system, and we are going to pass these damage arguments to all the health components, which will go where they are going to handle the life and the damage. The other part is applying the heat decorators. As I said, this comes apart. Heat decorators are defined in the heat itself, and what we do is just basically process this heat decorator. and we pass the entity and the arguments, and everything will happen inside the heat decorator class. Let's have a look to the noise heat decorator. What it's doing when we call the process method over here, what it's going to do is to look in the entity target if there is any heat decorator processor related to the noise. If it has any processor for the noise, it will just process this heat. And here we have our enemy controller class. This enemy controller class is implementing three different heat decorator processors: the pushback, the noise, and the status change decorator. Let's take a look to the noise heat decorator, which is the one we are actually interested in. So it is very simple. When we get the noise decorator, what we're going to do is to make this enemy enter in a noise alert state. And this is done through the state machine system. And this happens all in this method over here. And that's it for today's video. If you found it interesting, please subscribe. Thanks for watching.